Alright, so what I want to look at is, in this particular reaction, I'm going to combine ammonium carbonate and aluminium chloride solutions. Now, if I look on my solubility table, hopefully I've picked out here, like the carbonates are all insoluble, but ammonium carbonate is on there as soluble. So that's all good, that's working out. And for my chlorides, they're all soluble except for these two. So aluminium chloride is actually soluble. So I'm off to a good start in my example. I haven't accidentally tried to do a precipitation reaction with a compound that is insoluble. So now let's look at, well, what could they possibly produce? This is a cation and this is an anion. And this is a cation and this is an anion as well. The carbonate has a 2 negative charge. The ammonium ion has a single positive charge. That's why we've got this balancing 2 down here. It's saying I need 2 lots of ammonium ion to balance the carbonate ion. The aluminium ion is a 3+ ion, and the little 3 down here tells me that I need 3 chloride ions to balance out the charge there. So aluminium chloride is made up of 1 aluminium ion with 3+ charge and 3 chloride ions with a single negative charge. Ammonium carbonate is made up of 2 ammonium ions and the carbonate ion. So when I combine them together, the net charge is 0. Alright, now to see what happens when I combine them together. I want to see, well, what can I find out about ammonium chloride, and what can I find out about aluminium carbonate? So I'm going to look up aluminium carbonate and ammonium chloride. Well, I go back to my chlorides and they're all soluble except for silver chloride and lead chloride. That means ammonium chloride must be soluble because it's soluble except for those exceptions. So therefore this is soluble. And then if I look up aluminium carbonate, it says that they are all insoluble except for these ones here. And I'm looking to see, well, is aluminium listed as the cation? No, it's not. So my aluminium carbonate must be insoluble. So yes, I am going to be writing out a precipitation equation for these two. Now I need to balance this. I know that my ammonium chloride, the ammonium ion has a single positive charge and the chloride ion has a single negative charge. So they're going to combine in a 1-to-1 ratio. And then for my aluminium carbonate, the aluminium ion has a 3+ charge and the carbonate has a 2- charge. So in order to balance them, I'm going to need 2 aluminium ions and 3 carbonate ions. Okay, because that'll end up adding up to +6 and that ends up adding up to -6 because we want no net charge. So our charges have to balance. So that means that my aluminium carbonate will be Al2CO3 3. Now we know what we've produced, but our equation's not balanced. According to this, I need 3 carbonates, and I started out with only 1. So when I'm balancing an equation, I have to use my coefficients to balance. So I'm going to try a number 3 out the front and see if this is going to work out for me. Now my carbonates are balanced. This would tell me that in each of my ammonium carbonates I have 2. Remember, I have 2. But now I've got 3 lots of that. So I've got 6 ammonium ions. I would need to put a 6 here in order to balance out the ammonium ions. 2 and the 3. 2 times 3 is 6. Okay, our ammonium ions are balanced, our carbonate ions are balanced, and now I'm going to look at my aluminium and chloride ions. I know I need 2 aluminium ions, and so aluminium's balanced now. And the 2 times 3 is 6. It says 6 chloride ions, and I've got 6 chloride ions. So I've now balanced my equation. Full molecular balancing. Now to move on and we'll look at a full ionic. It tells me 6 ammonium ions. The 3 is also telling me that I've got the 3 carbonate ions. 2 aluminium ions, 2 times 3 is 6 chloride ions, 6 ammonium ions, 6 chloride ions, and then our precipitate, the aluminium carbonate. This is a full ionic. The net ionic is where we remove the spectators, and the spectators are the ions that are unchanged on either side of the reaction arrow. So anything that we've written in the same way on either side can be removed. This leaves me with 3 carbonate 2 aluminium ions, producing Al2CO3 solid. And I can also say that my spectator ions, the ammonium ion and chloride ion. Okay, so we need to be using the table in conjunction with knowing how to balance the substance, how to write it out properly to start with, making sure that we end up with no net charge. And then once we've got our substances written out correctly, we can then use the coefficients to balance out the ions that are present. So there's a few steps involved in balancing a net ionic equation. Now, is that enough of a run through? That's got you going again?